This video is on evaluating expressions, but before we begin, let's take a look and see where evaluating expressions falls within the larger context. So this is part of a series of videos on foundations of algebra that are needed for us to go further. So here we go. We'll start with evaluating expressions, and you can see after that we'll begin to look at solving equations and inequalities. We'll look at solving compound inequalities and absolute value equations. So there's a bunch more to come, but for right now, evaluating expressions. When it comes to evaluating expressions, there are three important concepts to consider. One is the definition of what does it mean to evaluate. The other thing is how do we evaluate mathematical expressions? One way is to use, and one important part of that is to use order of operations so that we all get the same result when looking at the same mathematical expression. And the other thing is substitution. Sometimes when we have a mathematical expression that has both variables and numbers, we might want to see what the expression looks like, what is the value of it when we plug numbers into the variables. So let's get started. First, the definition. The concept of evaluation means to determine the value of something. So that's what we're going to do. We're going to try to evaluate expressions, and when we do that, we're going to try to determine their value. The first important part of evaluating an expression is doing things in the proper order. We call this the order of operations, and we're going to demonstrate by evaluating a numeric expression. And we're going to start with something that I've seen on the internet quite a bit. I'll call this a viral math problem. This is one of many. And in this case, the question is asked, could you find the value of this expression? And many people get different answers. So we'd like to figure out a way to make it so that we all get the same answer. Now, before I go any further, what I'd like you to do is pause the video, and I'd like you to try to evaluate this expression, and let's see if we come up with the same answer. So go ahead and pause. Okay, hopefully you had a chance to try to get a value for this yourself. Now I'm going to explain the process that we're supposed to use. Again, we're going to try to use order of operations, and it's based on this thing called PEMDAS. We start with parentheses, we'll do whatever in parentheses first, then exponents, then multiplication, then division, then addition, then subtraction. Although this is a little bit misleading, because we don't always do multiplication before division. And in fact, that's one of the big problems that people run into in this example. If you take PEMDAS too literally, you will make a mistake. Multiplication and division are considered the same priority, so we will do whichever comes first as we move from left to right. The same is true for addition and subtraction. These two are the same priority, so whichever one we run into we'll do first when moving from left to right. We'll always do division before addition. We'll always do multiplication before subtraction. But if we have just subtraction and addition, we do whichever comes first as we move from left to right. Same with multiplication and division. So let's take a look at this problem. In this case, the mistake that many people make is they want to multiply the 2 times the 1 plus 2 first, because they believe in PEMDAS that we should do the multiplication first. So the result that we get is that most people get is 6 divided by 2 times 3, and then they say, okay, we got to do multiplication first. So 6 divided by 6 equals 1. And unfortunately, that's the incorrect result. Technically, what we're supposed to do is we're supposed to do this division first. And we're supposed to pretend as though that the 2 in the parentheses is really 2 times 1 plus 2. Remember, this means multiply 2 next to the parentheses. So if this is the case, and as we're moving from left to right, we get to division first, we're going to do 6 divided by 2. That gets us 3. And then we can do times whatever is in here, and that gets us 3. And so the correct answer is 9. Now, I'd like to take a moment and make a note here that although 9 is the correct answer and 1 is not correct, technically, when we use order of operations, I'd like to make the point that if the intention of the author of this problem was for anybody else who saw it to get the same answer as them, they've written it in a horrible fashion. This problem could have been written more clearly to make it very obvious how to get the correct answer for everyone who sees it. It could have been written like this: 6 divided by 2 in parentheses, in other words, do that first, and then times 1 plus 2. So good communication is as important in math as it is in any language, including English. Let's take a look at one more quick viral math problem. I'll let you take a stab at it first, and then we'll talk about it. Again, go ahead and pause the video and try it yourself. Okay, hopefully you now have what you think is the correct answer, and what I think we need to do is first we'll say, hey, we're going to have to do this 3 times 3 first. Multiplication comes before all of these others, division, addition. Well, certainly it comes before addition and subtraction. And if we do that, we end up with 3 plus 9 minus 3 plus 3. Again, don't fall into the trap that PEMDAS says addition comes before subtraction. We do not want to add this 3 plus 3 before anything else. Instead, what we'll do is we'll add the 3 plus 9, that gets us 12. And then we will go ahead and 12 minus 3, even though this is addition, well, that'll get us 9 plus 3. And so the correct answer should be 12. All right, hopefully you enjoyed that one. Let's talk about it a little bit more real quick. I'd like it if you could try 1, 2, and 3 here. Try to evaluate these numeric expressions and see what answer you come up with. In a minute, I'll walk you through my thoughts. Okay, hopefully you paused the video and you got answers to all of these. This first guy is one that tricks people regularly. The correct answer should be -9, and it's very possible you got +9. And you probably had very good reason for it. You probably thought, well, aren't we, when we square a negative number, don't we get a positive? Isn't negative times negative positive? Well, the problem here is we're not squaring a negative number. If we did something like this, if we did -3 in parentheses squared, that would be -3 times -3. That is not what we have. So what is it that we have? Well, what we have is something more like this. It's -1 times 3 squared. And if you notice, if you think about it, if we did something like -1 times 7, you'd expect to get -7. And if you did -1 times 5, I hope you'd expect to get not 7, but -5, right? And so what I would like to convey to you is if we do -1 times 3 squared, we get -3 squared. And if this is the same as this, we've got to apply this exponent to the 3 before we ever multiply the -1 times the 3 squared. And for that reason, we get -9. Now, another thing I'd like to bring up is we can verify this sort of thing using technology. And I'd like it if you knew the math, and I'd also like it if you knew how to verify your work using technology. So let's take a quick look. For those of you that haven't heard of it, there's this nifty little thing you can find on the internet called Google. And when you go to search for stuff in Google, you can also pretend like it's a calculator. So you can do stuff like 2 plus 3, and if you do, you can see here, well, that equals 5. Yay, great. And we can do fancy calculations like 5 times 8. I have to use an asterisk symbol to make the times, but still I get the answer is 40, so that works. So let's see what happens if I do -3 to the power of 2. Oh wait, first let's do 5 to the power of 2. Again, we have to use a fancy symbol in order to do power with Google. This is known as a caret, and the way we get this caret symbol is that, this guy is the caret right there. The way we get that, it's if you're using a keyboard, it's Shift 6 on the keyboard. It's the symbol right above the 6 on the keyboard. And we can see that 5 to the power of 2 gets us 25. Let's try it with negative 3 to the power of 2. And sure enough, Google says negative 9. And we can go further. Google will actually let us see the calculator. And when we look at the calculator, we can see the result is negative 9. And in fact, if we wanted to in Google, we could actually punch in negative 3. And then we can raise that to the power of 2. And then hit equal. And when we do, we can see, yeah, Google sure enough believes that that's negative 9. Now, I'd love to go on and on about this. Would be happy to talk to you more about this in class. But in the meantime, I wanted to show you using order of operations why negative 3 squared is really negative 9. And I also wanted to introduce you to the idea that you should be using a calculator in order to verify your results. Let's finish off these next two pretty quick. 2 plus 3 squared. Common mistake is to square the 2 and square the 3 and add them together. That would get us 4 plus 9 is 13. But technically what we should do is 2 plus 3, that gets us 5. Do the parentheses first, then square it, that gets us 25. And hopefully we can all agree that's the correct answer. Then next, 2 times 3 times 4. Doesn't matter that the 3 times 4 is in parentheses. Well, it kind of does. For PEMDAS, we'll do the 3 times 4 first. That gets us 2 times 12. And then 2 times 12 gets us 24. So hopefully we're in agreement about the results here. So finally, let's take a look at an expression, an algebraic expression that involves variables as well as numbers or constants. And let's go ahead and see how we have to evaluate this sort of expression. We're going to add a new trick to our bag of tricks. In addition to using order of operations, we'll use something called substitution. So what do I mean by that? Well, with substitution, if I have an algebraic expression that looks like this, and I'm told that x equals negative 3, what I'd like to do is I'd like to substitute in the negative 3 and wherever an x exists, and then I'll evaluate the expression. So in order to evaluate expressions, we may need to use order of operations, and we may need to use substitution as well. In this case, we will substitute in the x equals negative, we will substitute in negative 3 wherever we see an x here. Now, one thing that I want to point out that's really important is that whenever we're substituting, we're going to pretend like whatever we're substituting into, in this case the variable x, we're going to pretend like that x is a set of parentheses. And we're going to do this again and again and again throughout all the work that we do in this class. And the reason we do it is to keep ourselves out of trouble when the value of the variable is negative. So please play along with me and replace the x's with parentheses. And then let's go ahead and try substituting in the negative 3. By the way, some people may refer to substitution as plugging it in. We're going to try to be a little more formal. So we'll substitute negative 3 in here in place of x. So x is negative 3 and x is negative 3, and this will get us a value. We can go ahead and compute this. So using PEMDAS, we'll go ahead and apply this exponent first. So this will be, we'll leave the negative sign out in front, and then this guy right here will become positive 9. Negative 3 times negative 3, because this whole thing is being squared, the negative sign and the 3. Next, minus a negative 3. That we don't even need the parentheses. We could rewrite it as minus just negative 3 if we wanted to. And then minus 7. And then finally, let's go ahead and do, when we do minus a negative 3, that is a lot like, well, there's a couple of things we could look at, but we'll say that is like plus a positive 3, and then minus 7 finally. And that gets us negative 9 plus negative 7, negative 16, plus 3, and that gets us negative 13. So hopefully that is the result that you came up with. One last thing I'd like to look at before I leave this discussion of evaluating expressions is the idea of simplifying an expression. what I'd like you to do before I get started, though, is pause the video, and I'd like you to evaluate this expression when x equals -3. Go ahead and hit pause, and then go ahead and try it, and then together we're going to check and see whether we agree. Okay, hopefully you had a chance to evaluate this expression with x equals -3. Now, here I introduce the idea of simplifying an expression. In the other parts of the video, I talked about evaluating an expression, and that meant figuring out what the value was. But here, before we even begin to evaluate, we're going to try to simplify first. So in this case, instead of taking -3 and putting it here and here and here, what I'm going to do is I'm going to go ahead and do some math. I'm going to go ahead and distribute the -3x times the 2x, -3 times -7, and then we'll subtract the 4x minus 5. So here we get -6x squared, -3x times 2x, and we get plus 21x, and then minus 4x, and then plus 5. Now, I don't know that I've made this a whole lot more simple, but I still have to put the -3 in at 3 spots. But in some cases, when we simplify, we will have a better situation than what we started with. So it's always worthwhile to try to simplify the expression before you evaluate. So let's now go ahead and plug the -3 in. I mean substitute the -3 in. So again, I take the x's and I make them into parentheses, 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 and then we go and we substitute in the -3. And now let's go ahead and use PEMDAS and do the math. We square this guy first, so that'll be +9. -3 times -3, and then times -6, that'll be -54, and then minus 63. And then -4 times -3, that's plus 12 plus 5. And this all adds up to -100. Now, again, the last thing I'd like to say here is I encourage you to try to do this math mostly in your head or with pencil and paper first, and then verify using the calculator. And when you verify using the calculator, make sure you have a good scientific calculator or a graphing calculator, or if need be, Google. And if you can type it in so that you can see the whole equation, you're going to get a more accurate result rather than the old-fashioned calculators where you type in one number at a time and the previous number disappears. Here we can see what we typed in, we can see what Google thinks it is, and then we can see the result. And here we can be more confident that the calculator did the calculation correctly. All right, just wanted to leave you with that.